Video is on approximating irrational numbers on a number line. For the first part of this video, we're going to review what rational numbers are versus irrational. So we're going to take each of these numbers and place them into either the rational or the irrational bubble. Starting with 0.8, 0.8 is a rational decimal because it stops. It does not have the ... at the end of it. Rational because we can solve the square root of 64, which is 8. 8 times 8. 0 is also rational because it's a whole number. All whole numbers are rational. The square root of 32 is irrational because we cannot solve the square root of 32. No number times itself. Negative 19 is a whole number, and so that's going to give us a rational number. Negative square root of 100 is also going to be rational. We can solve 10 times 10 to get 100. 2.34344434 with the ... dots at the end of it is going to be irrational because it is not repeating. Even though there is a pattern, it's not the same pattern over and over again. The fraction 3/7 is going to be rational. All fractions are rational. The square root of 75 is going to be irrational because we cannot multiply any number times itself. The fraction 6 2/7 is going to be rational. All fractions are rational. The decimal 12.67 repeating is rational. All repeating decimals are rational. The square root of 121 is rational. We can solve that into 11 times 11. 12 over 5 is rational because it's a fraction. All fractions are rational. And the last one is pi. Pi is irrational because it's a symbol. Now, to get into the actual number line problems. For number 2, we're going to graph and label each number on the number line, and we're going to label the number line with the corresponding letter. So for the first problem, letter A is 0.75. On the number line, it would be represented here because 0.75 is greater than 0, but it's less than 1. And so that is the only point that's greater than 0, but less than 1. And so we're going to label that point A. Now for the second one, we have the square root of 3. We cannot solve the square root of 3, so we're going to split it apart into what we can solve. We can solve the square root of 1, which is 1 times 1. And we can solve the square root of 4, which is 2 times 2. The square root of 3 is in the middle of that. So we want our answer to be between 1 and 2. The only point that is between 1 and 2 is this point here, and we will label that with the letter B. Now for point C, we have the square root of negative 9. We can solve the square root of 9 is 3 because 3 times 3 is 9. And then we put the negative sign back into the problem. The point that's located on negative 3, we label it as point C. For letter D, we have the problem negative 2 1/2. So we go to negative 2 on the number line, and then we go just a little bit farther. And so we will label that point D. Negative 2, and then 1/2 is in the middle. For point E, we have negative 15 over 10. This is an improper fraction, so we need to rewrite it. 10 can go into 15 one time, leaving me with 5 left over. So that would be 5 over 10. 5 over 10 as a fraction can be simplified. 5 divided by 5 is 1. 10 divided by 5 is 2. My fraction would be 1 1/2, but we also have a negative sign, so that would be a negative 1 1/2. When we're placing our number on the number line, we would start at the negative 1. We also have the fraction 1/2, so we would go a little bit further and label that point E on the number line. Halfway in the middle is point E. The next one is going to be 2.6 repeating. We start with 2 as our whole number, and then we have the decimal 0.6 repeating, so we know it's going to be larger than 2. The only point that's larger than 2, we label it as point F. For next point, point G, we have the negative square root of 2. We cannot solve the negative square root of 2, so we break it down into what we can solve. We can solve the square root of 1 as 1 times 1. We can solve the square root of 4, which is 2 times 2. So we know our answer is going to be between 1 and 2. Because it's negative, we know that our answer is going to be a negative 1. We've already labeled E, so that means that the other point is going to be labeled as letter G. For our last point, we have pi. We know that pi is represented by the number 3.14 ... It has a bunch of random numbers after that. So we want our number to be greater than 3. There's only 1 point left, and so we label that letter H.